All right, and now for number 9, we have a classic. We have the cross-section of a scale model of a hill is modeled by the following graph. So technically this is a hill, maybe there's a tree on the top, who knows what the hell's going on, okay? Whatever, it's a hill. The heights of the model are measured at horizontal intervals and are given in the table. So they're telling us that for at x of 0, we have y of 0. So that means we have the point 0, comma 0 right here. At x of 10, we have a y of 3. So that means we have this point here is, you guessed it, 10, comma 3. And if we keep going, we have the same idea. This is 20, comma 8. Over here, we have 30, comma 9. And lastly, we have 40, comma 0. Okay, so that's the information the table is giving me. It might be useful or it might not. Let's see. Part A. Use the trapezoidal rule. Oh, shit. Use the trapezoidal rule with h equals 10 to find an approximation for the cross-sectional area of the model. All right, guys. So a lot of you probably read this, you read trapezoidal rule, and you're like, damn, I don't know what the fuck that is. So let me give you a little bit of a 101. Okay, so the trapezoidal rule, the reason you use it is because it is, as it says here, an approximation for area. Okay, if you want to find the area of this hill, right, like all the earth underneath, if you want to think about it that way, if you want to find the area or what's in red, okay, finding the area of something with curves, like this here, of something with curves, can be very hard, okay? For example, if I say, okay, what's the area of, I don't know, like a rectangle? Well, you tell me what's the height, what's the length, you just height times length, you're good to go, right? It's easy peasy when it's like straight edges, straight shapes, whatever, okay? In this case, you have a figure with a bunch of curves, and so what the trapezoidal rule does, and I think it's very important to understand intuition, what the trapezoidal rule does is that it takes each of these points that I just wrote down and makes a bunch of, you guessed it, trapezoids. Okay, so what you end up with are a bunch of figures that look a little bit like this. The trapezoidal rule says, okay, so I have a shape that is something like this. I have a shape that is something like this. I have a shape that is something like this, okay? And of course I missed one over here, probably looks like that. See? So if you find the area of number 1, number 2, number 3, number 4, you're going to end up with pretty much the area of the hill. The thing is, clearly there are some parts that I'm missing. For example, I'm missing this whole section here. I'm missing a little bit of this. You get the idea. When you use the trapezoidal rule, yes, you get very close, but you don't get the exact value. But it is very good for making approximations, and it isn't an integral, so it's a little bit more friendly, okay? So that is what the trapezoidal rule does. It finds an approximation, as I put here, of the area for whatever thing. In this case, blah, 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 cross-sectional area of the model. Okay, sure. It's just another way to say area, just very fancily. Just whatever, man. Fuck you. Trapezoidal rule helps you find the area under a figure at its approximate values because it draws a bunch of shapes. It finds the areas of the shapes. Now, if you're at the test and they tell you trapezoidal rule, well, first of all, freak out for 1 minute because trapezoidal rule is fucking weird. But then relax because you're gonna remember this video and you're gonna remember that some guy online told you, yo, the day of the test, you're going to walk in with a couple of things, okay? You're going to walk in with your calculator. You're going to walk in with, I don't know, pen and pencil. You're going to walk in with like 2 hours of sleep. You're going to walk in with a lot of motivation. Maybe a little bit of teenage depression. I'm not sure. Depends on each case to case. And you're going to walk in with your brain. Very important. You always have your brain. It's your, you know, it's your friend. It's your brain. And the formula booklet. Okay, guys, the day of the test, these are your tools. Okay, so get familiar with them, particularly the formula booklet. Okay, so within the formula booklet, you might not know the trapezoidal rule by heart, but you will know that the formula booklet has it. Okay, so you open up your formula booklet the day of the test, and you try to find trapezoidal rule. See, so you're probably just gonna start looking through the pages. You're not gonna care about the chapters, but eventually you're gonna find doop de doo da 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 da. There it is. See, trapezoidal rule. Okay, trapezoidal rule looks a little bit weird. Yes, I fully agree. But let's really try to understand what this formula is telling us. Okay, so first things first. Here you have this symbol there. See, this symbol there means an approximation. Okay, and so much as I told you, it's like the integral that calculates the area perfectly. You can make an approximation using the trapezoidal rule. Okay, so the trapezoidal rule is actually this. This is the trapezoidal rule. Okay, and where is the part where you have like these shapes going on here or there? Let me explain. So you don't have to understand this formula by heart, but really just understand what's going on. So notice how you have a bunch of y's. Okay, y is related to what? Ah, it's your y-axis. And your y-axis, is it horizontal or vertical? Y is your vertical, x is your horizontal. Okay? So you can think about your y values as like how tall something is. Okay? So each of these y values is like the tallest point you can find. See? Notice how you have from y0 to y1, y2 until yn minus 1 and yn. Okay? I know that's like, okay, what's going on? Basically, when they talk about y0, okay, it is your first value for y. And when they talk about, I'm actually going to write that down. This is important. So y0 is first value for y. That's why they call it y0. And yn is going to be your last value for y, okay? That means that y1 is, you guessed it, it's going to be, well, technically your second value, okay? Because your first is on y0, see? For y. And yn minus 1 is going to be your second to last, penúltimo, ¿cierto? Second to last value for y, okay? Now, I know right now some of you are thinking like, dude, what the hell is going on? Just focus on the fact that you have a bunch of y's and this subindex, okay, whether it's 0, whether it's n, whether it's 1, 2, 3, is a signal for which y it should be, okay? So the most important ones to define right away are, of course, the first and the last, okay? So looking at this graph here, which is my first y? This point here is technically x0, y0, see? So that means my y0 is, actually, let's make a little table here, why not? So my y0 following this is 0, see? ¿Cierto? This guy with this guy, right? The second point is x1, y1. So my y1 is 3. My y2, well, I have x2, y2. It's the next point that they give me. How did I find these points? It's the table that they gave me here. Okay, it's arbitrary. You define it, but they're usually going to give you the points. Okay, x2, y2. Y2 is going to be 8. By now, you guys have probably got the idea. So that means that y3 is over here with equal to 9 and y4 is equal to 0. Okay, so y3 is equal to 9 and y4 is equal to 0. See? Now, some of you might be thinking, okay, so right now I have this guy, I have this guy, this guy. Technically I have this one because like second to last would be, well, this y3. But you might be or maybe you don't even have that figured out. Maybe this is still confusing. Which one is your last y? Because I don't see a yn here. I see y0, 1, 2, 3, 4. So which one is my yn? Guys, what is the intuition of this n? I told you, it is the last value for your y. And in this context, what is the last value for your y? It is 0. At what location, at what slot? At y4. Ah, so y4 is the same as yn, and I put yn in the context of it's my last, okay? So your last, or your yn for the formula is going to be 0. Ah, so now when I write down the formula, 1/2 h parentheses parentheses y0 plus yn, blah, 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 plus, oops, plus 2, and then I have y1 plus y2 plus whatever this is, which I'm going to explain in a moment, plus yn minus 1. Here, the yn, your last one, is going to be this guy there, see? Now, some of you might also be a little bit confused with what is this here? See, why is there a dot, dot, dot? Notice how it's a sum, see? So it's saying it's y1 plus y2 plus dot, dot, dot plus yn minus 1, see? Now, this might be a little bit confusing because of the n, so let me land it a little bit. See, let me land like what's going on, whatever, see? Aterrizar la volada. Let me like bring it down to earth, okay? So imagine instead of yn minus 1, focus up here. Imagine I have y5, okay? So what this dot, dot, dot is doing, actually, what the dot, dot, dot is doing is just this. It's a way to write down less stuff, okay? Technically, the dot, dot, dot is this. So you have y1 plus y2, and here goes the dot, dot, dot. Watch it. The dot, dot, dot is y3 plus y4. And then I finish off with what I had before, y5. See? So the dot, dot, dot is just a way to like, yo, it's a long string of numbers. I don't want to write them down, but you get the idea, okay? The thing is, when you work with n minus 1, it's like, yo, basically just take all the y's until the second to last. Ya hasta el penúltimo, ¿cierto? So that's the dot, dot, dot. So in this case, because I don't have so many y's, technically my equation is just going to end up being, well, the first half remains the same. Vale? So this still remains the same. Here I have a 2. Here I have y1 plus y2 plus y3. And until there, ¿cierto? Because technically, sorry, something I missed to do, the yn we said was my last, ¿cierto? So this is going to change to y4, see? So my last one was y4. That's why I put it like that. My second to last was y3. How do I know it's second to last? Well, because here I put all my y values. Which one is second to last? y3. So, yeah. That is a slight change in the formula, but now it's a lot more friendly, isn't it? See? So guys, I spent like maybe 10 or 12 minutes explaining like what the formula does, why you use it, because it's an approximation, where you get the y values. But now that you know how it works, boom, you just get it right away. Okay, it's not that hard, but you do need to be familiar with it. Okay, and that's why I insist so much in all of my videos. Dude, get familiar with the formula booklet. Okay, a lot of these problems are not that hard. You just need to know a little bit of intuition and it gets you a long way. Because there's a bunch of people around the world that open the test, they read Trapezoidal rule, and they're just like, fuck, I didn't study enough, I have no idea what it is. You know? Okay, that happens to anyone. That it happens to anyone and everyone at some point. The point is, you gotta know this stuff before the test, okay? And no, you're not gonna know everything by heart. But god dang it, it's not that hard to know by heart the formula booklet, okay? And more importantly, it's knowing sort of what goes in it, okay? Point is, you arrive to the test, you read Trapezoidal rule, and you're like, damn, I know that's kind of hard, but what tools do I have? And you remember the formula booklet, and you open up the formula booklet, and yes, it looks weird, but now that you watch this video, you understand what is what. You understand that this is first value for y, you understand that this is the last value for y, and these are all the ones that are in between. See? And with that, you're good to go. See? And no, I didn't explain what h is because in this exercise, they give us h. Okay? How do you find h? Well, notice how it's b minus a. Well, that's basically like a is going to be your first value for x, and b is going to be your last value for x, okay? And n is just sort of, well, if n is the last value for y, so in this case, we would have n equals 4, see? So, well, yeah, actually, here they give us h, see? But you can actually find h with what I just told you. So my first value for x is 0, see? So that means in this formula, h equals b minus a divided by n, I already have that the a is 0. See? I said that the b is the last value for x, so that means the last value for x is this guy here, right? 40. So I'm going to have 40. And n, well, n comes from the last value for y. We said that the last value for y was y4, so that means n equals 4. Ah, okay. So 40 minus 0 divided by 4, 40 divided by 4, 10. H equals 10. See? So here they gave us 10. I mean, here they gave us that h equals 10 from the exercise. See? But even if they didn't, we can get it really easily. Okay? So guys, really, just if you know the intuition, you're good to go. Yeah? Alright, that was a very long introduction, but I'm sure some of you don't know trapezoidal rule at all, so I'd rather just be a little more, complete in my explanation. See? Point is, I rewrite my formula to make it a little bit more friendly. I don't have any more n anymore. I have a 4 here. I don't have n minus 1. I have a 3 here. And now I'm good to plug in. See? So we know that h equals 10. This over here is an n. Okay? Just to show that the last value for y is going to be your n. So now I plug in. I'm going to plug it in red. See? So if I go 1/2, I'm going to have 10. y0 we said is 0 plus 0 because of y4, ¿cierto? Plus 2 times y1 is 3, plus y2 is 8, plus y3 is 9. See? So give me a second. I plug all of this in into my calculator, and trust me, you're going to get 200 centimeters. Because it's an area, we write it squared. So the trapezoidal rule, and this is part A, the trapezoidal rule gave me 200 centimeters squared. Then they tell you that it is given that the equation of the curve is y equals 0.04x squared minus 0.001 x cubed with x between 0 and 40. This makes sense because between 0 and 40 is literally from here, from this 0 to this 40. See? Okay, so write down an integral to find the exact cross-sectional area. So, again, much like trapezoidal rule helps you find the area, just in an approximation, the integral helps you find the exact area. Okay, so that is a way you can remember it. An integral is for finding the exact area under a curve. The trapezoidal rule is to find the approximated area under a curve. See? And to write down an integral, it's super easy. I mean, and it actually sort of comes from the formula booklet. Let's remember that. Let me make a little bit of space because I did write down a lot of shit. So the part of the trapezoidal rule that is actually the trapezoidal rule is this guy here. See? This is the trapezoidal rule. Okay? Over here, you just have like a normal integral. See? And what's cool about the trapezoidal rule is that it lets you do the approximation. Okay? From an integral. Yeah, it lets you do an approximation, find the approximate area, blah, blah, blah. See? And so when they tell you, yo, write down an integral. See, the first thing you're going to do is write down an integral. This symbol here, see? And we're going to talk about what's B, what's A. Or more of a review because I already mentioned it. So you're going to put down the integral. Let me use a different color just to, because I'm like that. This one, see? So you write down your integral, okay? And we have A and B, see? Now, what did I mention that A and B was? I said that A was going to be your first value for x, and B was going to be your last value of x. See? So, your first value of x, we said was 0, ¿cierto? So I'm going to go ahead and put 0 over here, right? Because A is on the bottom, yes. And the last value for x is 40. And another way you can figure that out, by the way, is here. See? You can actually say that this is A and this is B because of the domain that they give you, okay? If they don't give you a domain, just do like negative infinity to positive infinity, okay? It'll work, trust me. So, from 0 to 40, see, that is all my x values that I will be taking for today. All right, and now you see here how you have y dx. So dx is like in respects to what variable you're making the integral, and y is just your function, okay? Okay, so if you have y dx, and actually in the answer key you can leave it like this, but for something that makes more sense to us humans, y is your function, right? So let me go ahead and put a parentheses here. So parentheses is going to be my y. So my y is going to be y equals blah, 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 0.04x squared minus 0.001 x cubed, close parentheses, dx. See? So essentially, in math language, what you're trying to say is, yo, what is the integral of this from 0 to 40 of my variable x? In what equation? This equation. See? All right. So this is quite literally part BI. For part B double I, it says to calculate the calculate the value of the cross-sectional area to 2 decimal places. So basically, this integral we just wrote down is for finding the exact cross-sectional area. And now if we just calculate this integral, we find that area. See, so in other words, we have to solve this integral here. Now, I know a lot of you are probably saying, God dang it, I never understood integrals in class. I don't know what the fuck to do. I get the intuition, I know it's for an area, but what do I do from here? God help me, please. So, guys, check it out. One of the things you walk into the test with, besides your brain and 2 hours of sleep and all those jokes and blah blah blah, and the formula booklet, is the graphing calculator. Okay, so get familiar with the graphing calculator, get familiar with what it does, know your tools. Okay, at the end of the day, you face a problem, you look at your tools, you do the best you can. That's all you can do, not just in math, but also in life. Okay, so over here in this TI-84, if you have a different version, I'm sure you also have it. There is a way to plug in integrals. Okay, for the TI-84, you press math. I get you can do it here. Yeah, so you press math, and down here it's in the let me try again. You press math, then on the second column from math to num, okay, the second sort of page, you go down to number 5. It says int for integral. All right, actually, I'm sorry, I messed up, but I'm gonna leave it in the video because we all mess up sometimes, and we're all human. See? Again, get familiar with your calculator because then you can tell when you make a mistake and when you don't, right? All right. For the integral, you press alpha window. So what that does is that it helps you press F2. See? Now notice when you press F2, these 4 little tabs show up, okay? For fraction, for function, for matrix, and for y var, okay? So that means if I press alpha y equals for hitting F1, I open up the fraction menu. Over here the function, over here for F3 the matrix, okay? And so there are a lot of different things you can do. See, in this case, we're going for a function, the integral function. Here I have absolute value, uh, the sum of stuff, ¿cierto? But in this case, we are going for integral, see? Actually, you can do the derivative too. So whenever you have to do the derivative, this is a cheat sheet as well. Anyways, enough blah blah. We go to the integral, there it shows up, see? All you have to do now is plug in and plug in property. So here I have my a and b values. See, let's remember that a, the one on the bottom, is the first value of x, so 0, and b on top is the last value of x, 40. Okay, basically when you do that, you're telling it like from where to where you want to find the area. For example, if here I put 20 instead of 40, what I'm asking the calculator is what is the area from here to here. So you would find the area until you reach the x of 20. Okay, that is what the b value does in this thing. Okay, so again, we leave it in 40 because we're solving this integral I put in this black square. What is my equation? Well, it's right there in front of me, 0.04 x squared, and then we have minus 0.001 x to the power of 3. Don't forget to put dx. What does dx do? You basically tell the calculator in respects to what variable you want to do the integral in this equation. Okay? For us, we're pretty much always just going to use dx. whatever. You press enter, you get this value. See, so part B, part double I, you have 2.13. Wait, I messed that up. Sorry. You have 213.33. 3333333. See? Centimeters squared. Now notice they do tell you to answer to 2 decimal places. And so you count 2 decimal places, 1 and 2. Do you round it up or down? It stays the same because 3 is not above 5. So your final answer is actually this. This is your final answer. This is a 1. This is centimeters squared. All right. Last but not least, for part C, we need to find the percentage error in the area found using the trapezoidal rule. Now again, some of you are already thinking, oh my god, fuck, what is percentage error, dude? I never understood percent, dude, oh my god. Guys, get familiar with the formula booklet. I know I'm gonna drive you guys crazy saying that, but it's real shit, dude. I swear it's real shit. You might, if you know the formula booklet well enough to identify the buzzwords, the vocab words that matter, you're going to read percentage error and you're going to remember that it's in your formula booklet. You're not going to remember what the equation is, you're not going to remember how it works, but you know it's in there. So you're going to look for it, eventually finding percentage error over here. See? And you're going to read it, remember a bit what's going on, and it's going to be good to go. See? So first things first, this E is just like the value of the percentage error, okay? VA, as it says there, is the approximate value of V. And VE, of course, is going to be the exact value. Whoops. Come back, computer. Thank you. It multiplies it by 100% to turn it into a percent. Okay, important. And you might be a little bit confused on what this is. Okay, this is not a parentheses. This is what we call an absolute value. So an absolute value, what it does is that it turns any number positive. For example, the absolute value of 3% is just going to stay as 3%. As I said, any negative turns positive. The absolute value of negative 2% is going to turn into 2%. Okay? Absolute value of 0, it's just going to stay as 0. Absolute value of, I don't know, negative 7 turns into 7. Negative value of 9 turns into 9. You get the idea, okay? 125 positive stays at 125 positive. So whenever it's negative, it goes positive. That is what the absolute value does, okay? So you can basically just find your answer and make it positive, okay? So here, following this equation there, we have, well, first things first, I want to put it in a fraction because it's easier, so I can press alpha F1, and of all these options, the first one gives you a fraction, okay? So the approximate value, what might it be? Well, I did tell you that the trapezoidal rule is for finding an approximation. Okay, so my VA is going to be this. Notice, I'm going to put it in whatever, orange. See, so my VA is 200, right? And my exact, what I calculated with the integral is this, okay? So that means that I'm going to have my VA, we said was 200. My exact, we said was 213.33 divided by 213.33. Go ahead, press enter. I need to multiply by 100%, so I missed that. So just multiply by 100. Okay, so now it's in percent, so it's negative 6.24%. But because of the absolute value, it has to be positive, ¿cierto? So whenever it's negative, just think, okay, absolute value, it has to be positive. If you want, you multiply by -1 to make it positive, whatever, do your thing. Basically, your answer is going to be 6.248 blah 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 percent. See? So, for your answer for part C, ¿cierto? You're going to say that it's 6.248, 538, blah, blah, blah. If you do 3 significant figures, you're going to count 1, 2, 3. This one, do you round it up or down? It's an 8, so you round it up. You end up with 6.25%. Exactly as the answer key shows. All right, so that is for this trapezoidal rule problem. Now, guys, I know I spent a lot of time talking in the beginning, but I'm also sure some of you needed that. Regardless, trapezoidal rule usually shows up once per test. It's not that hard, but you do have to know it well, okay? As you can see, it's a very methodological. Dude, I don't even know how to say it, but the approach, the method that you use is always the same. Okay, so that's friendly in that sense, and you practice 2 or 3 of these, and it's they don't usually throw curveballs here. I think the biggest curveball was the percentage error, which again is just the formula that is in the formula booklet. If you're familiar with it, you'll survive. So in my, I think these are 8 easy points. Remember that for the integral, you can just use the calculator and forget about it. See, you can learn how to do it by hand. I don't like to teach it because I'd rather just teach like the easiest thing. I know some of you are probably watching this like a week before the exam, so might as well just give you the easy way out, the quickest way. Use your calculator, dude. There's so many tools in there. You have no idea, man. It's amazing you get to use a graphing calculator for a test, my guy. So yeah, I hope it helped. Take it easy. I'll see you around.